Welcome back, my name is Alex Angel and you're on my channel and watching the last part of this tutorial of my recent project Nuke. And this one is gonna be a pretty long one, but we will finalize everything. We will create all last elements, we will talk about the rendering, presets, all preparations and post-production of course. And we will begin with the rocks and debris. So let's begin. Now you can see the dust which we created in the previous part of this tutorial. Yeah, it's pretty heavy simulation, so we need to decrease a little bit the detail for the preview to make our 3D Max more interactive. And let's create the TyFlow object, because our rocks will be particles actually. Also, we need to create a TyFlow icon. We will define the direction of movement for our particles with this object. So we need to rotate it and point with the arrow the direction where our rocks are supposed to fly, so it must be directly to the camera. Let's start our particle system with the simple birth. And first of all, we need to define the frames where our particles should start emission. It must be just right the same as the simulation you see in the viewport, because actually particles must be just right inside this volume. Next thing, we need to create position object operator and target our ground emitter. And inside the slot of this map, we need to actually input the gradient ramp, but I think we can use the same map as we used in the source from this close up dust simulation, because actually it's the same gradient wave. So I think we can use this map. Yeah, actually this is it. We can use it. So just copy actually instance to this slot. Let's change the color to make it more visible, and change type to large dots. Maybe need to more particles to make it even more visible. Okay, but it is strange, but the dust is in front of our particles. It's because the time shift for 2 frames, you see, when it's original 0 is just right the same as the particles, but I use this timeline, so timeline origin, so we will create just a copy of this map and rename, so we cannot use the same map. Yeah, let's give the name and input this map to our particle system, so we will stay separate from our source. And now we can work with this map. We need to input as usual to the material this map to make it visible in the viewport as well. And let's check the graph. So since this was the copy of the map from the source, we need to move forward 2 frames forward these keys to match the time. See, now it's just the same time as the simulation cache. So next step, we need to create deflectors which will kill the particles unnecessary particles, so our system will stay clean and efficient. So the system doesn't have to keep calculating all particles, even those which are under the ground somehow or behind the camera. So we need to create several deflectors and place them like this, one below the ground with some gap. Yeah, like this. Also, we need the same deflector for the left side, right side of the ground, and the back side behind the camera. So let's make a copy and yeah, place it from the side of the emitter. So every single particle which fly outside of this perimeter will be deleted, because actually we will have a lot of particles and it is better to keep our computer not overwhelmed by this amount of flying rocks. Okay, one more copy for the back side. So this one will be just behind the camera. Yeah. Wait a second. Where's our camera? Yeah, this is it. It was in the wrong layer, sorry. Yeah, camera is here. So this deflector is just behind the camera. Okay. So now we need the operator collision, and let's add to the list all our deflectors and test action delete. Okay, looks pretty clean. Let's save our scene. Now let's try our simulation and see how the particles behaves. And yeah, emission is fine, but they are staying on the ground. So next thing, we need to add also shape operator, so we can define how our rocks will be on a render. And to move our particles, we need a operator speed, and speed will be in a mod which called along the icon, and we can point our icon which we created at the beginning, and now particles will move just along the arrow of that icon. Okay, the movement is fine. Actually, now it's hard to define is it right or not. So far, we need to. I think now we will create the collision, because first of all we need to make our particles to collide with the ground. So let's find another collision. Let's create this operator and add to the list our ground. And now you can see that the particles are actually colliding with our ground. Okay, and all particles which are outside of this volume, yeah, we can move a little bit our deflectors to make our particle system more efficient. So unnecessary one will be deleted. Let's save our scene, because you know sometimes your 3D Max can crash. And let's work with the speed a little bit. But first of all, to work with the speed, we need to see the trajectory. So let's add spline path operator and create the spline. So we will see actually the movement path of every single particle, and that will be better to understand. The result of our work with the speed. Okay, well, even without the splines, we can see that the particles a little bit too crazy. They're flying too far away, so let's decrease the speed value magnitude and change timing to the particle age and change it to 0, 0. So it will, every single particle will get the speed value only at its age of 0. And let's add force and bring some gravity to our system, and turn on the splines visible back. So now we can see how our rocks are moving. Let's give some variations to the speed and also some divergence, but not too much, because still our rocks must move to the camera, not to the sides, with just a little bit of variation. Okay, from the camera it looks okay. Let's decrease some gravity, add some speed. So basically you'll just play with the speed, with the gravity, with the friction. So you need just to get the look of the rocks nice in the camera, enough amount, enough speed, and feeling of the weights. Okay, let's add additional speed operator, and this one will be direction particle z axis, and in the mode add to the velocity instead of set, and also timing in the particle age 0. So what it will do, it will actually create some vertical speed as well. So we will push our rocks not just to the side, but also a little bit to the up. So next thing we will do, we will deduct from our wave of the emission the areas with the shader of rocks. So our emission of the small debris will be only from the areas with the sand shader. So we will take this map, which we got from Gaia, copy, go to our gradient ramp, go to the point, the white point, edit, and here inside this slot we will instance this map. Okay, and the rest of the points we will make black, because otherwise if they will stay gray, they will emit the particles from the whole surface. And now you see the result. The map doesn't take into account the areas with the rock shader on the ground. So let's copy this map to this temporary shader of our emitter, and we will see everything in the viewport. So press the button to make it visible. It's weird because we don't see it in the viewport. Let's check the mapping. Okay, the mapping is right. Let's delete this unwrap. Okay, let's take just the map instead of this composite. So yeah, we don't need whole composite, just take one map to our gradient ramp. Yeah, just vray bitmap, and bring it to the temporary material of our emitter to make it visible in the viewport. Okay, and let's hide our simulation. Okay, now we emit our rocks only from the sand area of our ground. Let's bring bounce to 0 from our deflectors, because we don't want to bounce particles from there. Okay, it's weird because I can see that the particles are still bouncing. Let's bring bounce 0 to here also to this operator. Change to continue, but still the right side next to the camera, I obviously can see the bouncing. That's weird. Something wrong. I was expecting to move the particles just towards the camera. But it looks like a bouncing from this deflector. Let's move them a little bit far away. Okay, that's weird. Yeah, they keep bouncing even without deflector. They're bouncing from the ground. Okay, that's even more strange. Okay, now it's correct without this operator. Very interesting. We need to find a solution to find the reason why these particles are moving to the left. Very strange displays, I don't know. Okay, what it can give such a movement? Oh, okay, now I see. Because it was black color, I didn't see, but actually there's a... Okay, it's a surface. They're bouncing from the surface, so actually it's correct. It is just because of my ground. Okay, if it's not a mistake, if it's correct by the system of the collision, then it's fine. Okay, let's keep it. Yeah, let's decrease some speed a little bit. Okay, now it looks much more better with the lower speed. Okay, let's make our particles smaller, because we don't want them to be that huge. Some variations, and make more particles. So 50,000 should be fine. Okay, I think we need to bring some friction with our ground. Let's rename this collision to specify which one is which. This collision is collision with the ground surface, and let's try higher friction, maybe 100. Okay, they keep sliding. It must be a reason somewhere, but let's check from the camera. Oh, okay, from the camera it's fine. So let's leave it as it is. maybe smaller, maybe even smaller. Yeah, I prefer to keep them as a small little rocks, not huge boulders. Okay, I think we can bring more particles even after our wave. Okay, again, problem with the UI. Yeah, let's check the graph of the movement. And this one, the lower one, is this point. So let's choose all points of this line and scale it down so you see the point on the gradient ramp. So our wave is much more wider now. So we create more particles. Okay, let's make this line visible. Yeah, now the line is much more wider in the middle of the animation, and we will emit more rocks. Okay, now it looks good. Maybe even more, because now we see all them static. It doesn't look good. We need more chaos to this system. So some rocks should still fly over and over again and again, even after the shockwave already passed. So let's change our frames for the simulation for the particles. And yeah, we see this wave, the first wave, and then we keep still seeing the particles are still flying, some rocks flying. Okay, maybe a little bit even more. Yeah, let's bring it even more down to make our line wider. So we will keep seeing particles. Yeah, and let's make more frames for the particle system. And yes, we keep seeing some lonely rocks that keep flying. Oh yeah. Okay, maybe even more frames. And amount, more rocks. Okay, first wave, and then these rocks I keep flying. Okay, it looks good now. Maybe let's change back to 1250. It's totally up to you how much rocks you want to see from the camera, but I prefer to have the wave, and after the wave I want to see some lonely rocks that keep flying to the camera, maybe like 5 or 10% amount, so it will give the feeling of the power of the shockwave, that it just keep pushing and pushing more and more rocks from the ground. Okay, let's see from the camera carefully, frame by frame. Okay, let's change a little bit. First of all, let's add the spin, and spin in a travel direction mode, and spin rate 1200 with some variations, so our rocks will spin towards their directions. And I think we can bring some variations to the shape, make it a little bit smaller, 7, and make a copy to the shape list, And with this copy, we will make bigger rocks, but frequency only 20%. So 20% chance to spawn bigger rocks, and one more duplicate with the even bigger size and even less frequency, but this one will be another shape, flat chunk. Yeah, even bigger. So we have three shapes for variations of our rocks: flat, small, and big one. Okay, now it looks pretty good. Now we can move to the next step and create a shader for our rocks, and try to render rocks and the dust wave all together, and we will see how it looks with the lighting and everything. So for this, let's select our simulation box and bring it back to make it visible in the viewport. Okay. And change the view to the camera, and let's go to the material editor and create our shader. It's a simple vray material, just to give the name, the color and reflections. You don't need any complex shader here because the rocks are very small and fast and also motion blur. So minimum, just minimum. I prefer to keep full off to the reflection map with some adjustments to the curve, and that's it. That's enough. Mostly it's all about the color. I didn't put even bump or anything. So glossiness 0.55. Yeah, that's it. We will change probably only the color. Okay, let's double check our render settings so we will not overwrite anything. Okay, let's give the name to our simulation box and create a selection set for this. So we will be it will be easy to select it again and again. Okay, so we are ready to make a render. Yeah, we need operator mesh to our system because otherwise we cannot see our particles on the render. And yeah, the color is not right. Okay, what else? We need an instance material for this and bring the material to the slot. Okay, nope. Okay, just assigned. Sorry, yeah, we need just to assign the material to the type flow object. Yeah, let's kill that operator. We don't need material instance. My bad. Okay, the color is fine. Let's just adjust the tone. This is totally up to you. I'm just trying to match the color of the ground somehow, but still keep it darker so it won't blend with the ground and also later with the dust altogether. Okay, let's set rendering with the higher settings and with the displacement. Okay, it's a little bit slower than usual rendering without displacement. I prefer to keep displacement off for every single render test because it consumes too much time. Okay, this is our rocks. Well, maybe too red, or maybe also too saturated, and yeah, darker and less saturation. Turn off displacement mode. Okay, it's much more faster without displacement. That's crazy. Let's select our dust and go to the render settings. Let's make a steps 400 so it will be calculated faster. We don't need too much details now. We need just the color from the simulation. For the final render, we will bring back steps percent to 90, of course. Okay. Yeah, we can see the rocks inside our dust. So the color is right, I guess. The only thing I don't like much that our dust is at the bottom of our frame and some rocks are in the sky. I would like to blend them together. So maybe too much vertical speed for our particles. Okay, let's see without GPU preview. Yes, our rocks are flying too high above the dust, and this is not correct. So let's decrease the amount to make it faster for preview, and let's decrease our vertical speed, maybe to value of 3. And bounce, maybe more bounce and some variations. Well, this vertical movements I don't like much. Yeah, there was too much bounce. Maybe 25 will be fine. 15. Yeah, with these splines it's so much easier to work with the speeds and all these parameters. So let's change gravity. And what else we can tweak more. Actually, the movement is okay. Let's decrease friction a little bit to make our particles slide just a little. Let's try without splines and inside our camera view. Okay. Yeah, now rocks are lower and more close to the camera. So let's decrease a little bit gravity. Okay, now it should be fine. So let's bring let's change the frames and bring back the amount. I think we can have more rocks after the wave. So let's try to adjust our gradient ramp probably. Yeah, it's not enough. All rocks are already on the ground. So yeah, let's go back to our graph and bring it even more down. So we will keep emitting even more. Okay, yes, it is better. we see more rocks are flying. Let's change the frames for the particle system. Okay, yes, this is what we need, the wave, and then some lonely rocks that keep flying. Okay, let's try to render and see. Okay, almost invisible. So let's make even more, 4 times more, 400,000. Yes, this is why we need the deflectors to keep our system more efficient, because otherwise our rocks will fly behind the camera and the simulation will be just insane. Okay, yes, there's one rock is flying directly to the camera. Yes, now we can maybe tweak a little bit more gravity. Let's bring back our simulation and turn on the GPU mode back. And how it looks. Okay, feels like I think we need a more to tune more our gravity, because it feels like yeah, too much rocks above the smoke level. So let's change our gravity to 0.7, maybe 85, or maybe even animated. Yes, and make gravity lower at the frame after the shockwave. Yeah, so now the rocks will have a animated gravity. So in the beginning they are low, and later they will fly higher. This is a nice solution, I think, for our case. And let's we can shift our the wave a little bit backwards, 1 frame, so our rocks will emit just 1 frame behind the dust. I think that will look better. So I will do the test render and you will see the sequence. So this is it. This is my test render with the dust, and it looks good. Maybe it could be maybe a little bit darker shader for the rocks, or maybe a more amount of the rocks, maybe not 400,000, maybe, I don't know, maybe 1 million. Yeah, and maybe darker colors, or maybe more rocks at this stage after the shockwave in the second half of the animation. Okay, now our viewport with this 400,000 rocks is quite slow. So the next step, we will make caching for our rocks, and for that we need another operator, export particles, in the mod type cache. Specify the frame range and output address and the name. Okay, everything by default. Let's generate. Okay, we don't need H. Yes, we don't need it because we didn't include H channel in our type flow. Yes, let's specify the destination of the cache files and generate the cache. So that's it. We have our particle system for the rocks. You just need to select the try cache and we need to also apply the material to the cache because it's another object. So that's it. Let's go to the next step. In this chapter, we will create additional element, the little flying dusty particles to visualize the wind effect, which you can hear in my original video of this project. So the start is pretty similar as the previous chapter. We need the type flow object, we need the icon, and we need to set a position of our icon from the side to the right side, from the right side of our camera. Don't mind this simulation box and these two objects, the plane force and the turbulence, that was just from the test. We will delete them later. So let's begin our particle system. The simple bursts display a red color, large dots to make them visible. Then we need a position object operator and pick our icon. And something wrong. Where our particles? Where are they? Okay, something. It is strange. Let's try it with the speed along icon arrow and choose our icon, but still it is not emitting the particles. Frames are correct. Strange. What's wrong? Sorry. I need to find the reason why it's not working. Looks like it doesn't read position. Okay. It is weird. Oh, okay, I see. Because the operator was position object, not position icon, but we still need the icon. So yeah, let's create just a plane, and the plane will be our position object, and the icon will be for the speed. Okay. Yes, now we have our particles. It was a problem with the recordings. As you see, the particle system also have a collision operator, and inside that collision I added our deflectors, which are from the previous chapter, to kill the particles outside the area of our emitter. Okay, next step. Oh, sorry, also I will delete these test objects, we don't need them. Next step will be force. So the force will bring some gravity. Later we will tweak this value a little bit more precise. And now we need a collision operator for our ground. Let's target our ground. And as you see, our particles are falling down on the ground. So yes, let's decrease gravity, because our particles actually have to fly above the ground, so the effect must be very, very subtle, very little. And let's give some variations with the noise. Also very, very little. because actually it's a little dust particles. Well, now it looks a little bit like a snow in the desert. Okay, let's bring some wind as well. Okay, something like this. And slow down operator. So our particles will be slowed in the air. Okay, let's tweak our direction of the wind. Okay. And decrease the slow value. And again, we will just play with the parameters of slow operator and the gravity and the speed operator to get the feeling that these particles are like a dust flying with the wind. Okay, maybe increase the slow value. Okay, maybe 3, 4. Okay, maybe 5. And let's change the start frame to 800, so it will give us 200 frames before our sequence starts. And it looks actually very good in the viewport. Yeah, looks like a dust. And let's change the display to geometry and add the operator shape. So we will give some shape to our particles. And let's create the material. Let's give the name to this material. And we just copy it from our rocks, because basically it's just a little dot, so it doesn't matter. Let's add the gradient ramp to opacity in the mod radial to give some variations and transparency. Yes, something like this. So our particles will be like half transparent, like a dust actually. And the size really small. And let's try to render how it looks. Almost nothing. But it is difficult to see in the static. It will be more visible in the motion. Also, I forgot the mesh operator, so it was impossible to see actually. Okay, now with this operator we can see our dust on the render. In the motion it will be even more obvious. Let's make less particles and change the size a little bit. Maybe play with the slow operator as well. Try value of 7. Also we need to start even earlier at the frame of 700. Okay, in the viewport it looks actually nice. Let's try to render. Okay, now it looks better in alpha channel, very obvious. Now let's try some subsurface scattering maybe for the shader to make the particles brighter. I don't know if it will work actually. Okay, on the render cannot see any difference. Let's see better on a test with the sequence. So let's change the size a little bit more. And let's try maybe a better quality of the render. Okay. Yes, we will see it definitely on the sequence. So the shader will be with the subsurface scattering. And the viewport looks really good. Actually, I like it. So let's add spin for our particles. So they will rotate again in a more travel direction. And the spin rate 700, is it enough? I don't know. Hard to say, they are very small. Maybe 250. It is difficult to track them with the eyes, so let's try 2D zoom in the viewport. Okay, yes, they are spinning definitely. Okay, I think this is what we need. Now we need to make sure that our shockwave sphere will vanish all these particles. Actually push or kill, doesn't matter, because it will be super fast. So let's add additional collision. Let's choose our shockwave sphere. And we will just bounce the particles. So that's it. All this dust just gone with our shockwave. Okay, let's unhide our rocks. And I will do, behind the recordings, I will make a test render and I will show you the sequence. Let's choose the camera. And this is the result of the test render. And yes, you can see this dust flying in front of the camera over the dark areas of the ground. It is very subtle effect, but this is actually what we need. It's just a little flying dust in the air. Okay, and now I will show you the parameters once more. It is 1000 particles. The speed is this value. Gravity is minimum. Speed, noise, and the slow operator back to 3. And this is it. This is our flying dust. And yeah, it looks really nice. With the wind sound effect, it will give really nice feeling of the desert and the windy weather. Okay, so now we can move to the next chapter. Chapter number 3, and here we will do actually the same effect but far away at the area of explosion in the dunes far away. So for that we will do actually the fake of the dust, not the real particles. So we need a box object and place it just a little bit above the ground with intersection with our ground object. Something like this. And we need more polygons to this box. Okay. And now let's add displays to this box. Where is it? Oh, displays, yes. And the map for this displays will be cellular map. Let's instance this map to material editor so we can edit size. Let's change the size to 20 and try our displacement. Okay, it's not good. We need a bigger. So basically this box will be and a bounding box for the vray fog, and this box will be also animated. I think we will adjust a little bit more our map, and just for the convenience I also will rename the displays modificator. Size 60. Okay, it's fine. Later we will animate the size value to make a kinda animation to this surface. Okay, maybe 85. And play with the spread and the strength of displacement. Okay, or maybe 25. Yes, 25 will be fine. Oh, sorry, I think I animated the display's strength. Let's Control Z this change. So we need the animation in a size of this map. So it will give us kind of effect of phase of this map, some change and an animation. Let's give the name to this map, low fog surface map. And this size animation, let's make it linear first of all, and move these points outside our frame range. So we will consistently have this little change in our displays, so it looks like clouds of the dust or sand in the wind above the dunes. Now we need a UVB map modificator for this object with channel 2 and one more displays with another name, and gradient ramp for these displays. Let's give the name to this gradient ramp, low fog wipe out map, and let's change it to radial. So by this map we will kill this object above the ground, so make it radial, and we need to locate our mapping just in the middle of our explosion. So let's choose UV map modificator and let's move it. Oh, sorry, our gradient map, not in the channel 2. Okay, yes, now it is in the middle. Let's make it a little bit bigger so it will not affect the tile of the map. And let's bring back our shockwave. And now we need to follow with this map our shockwave. Frame by frame, again, we will animate this point. It is very approximate. It's not. It is not necessary to be super precise. Oh, sorry, I created another point. So let's just follow the shockwave. I just make the keys every few frames, and that will be enough for this purpose. Okay, and till the end. Okay, so now we have a perfect map where our box, which is the emitter for the vray fog, and this box will be pushed inside by this map, and the only thing we need just to invert this map. Yes, and play with the strength and luminance center to play with this parameter and find the position where we have a kind of hole, yes, inside this box. Yes, something like this. And now this box, the volume of this box will be a bounding box for the vray environment fog. Later we will play maybe with the animation of the first displacement of the map from the first displacement. Yes, the only thing we need to animate the first frame of this top displace to make it inactive in the frames before the shockwave, so we will not have a hole in the middle. Now let's go to the environment and create environment fog. Let's give it a unique name because we already have another one. And for this environment fog we will choose Gizmo, our box. Also let's change the color and distance, which is density in our case, something about 125. Okay, now it's everything ready. Let's back to camera view, and for now we will turn off this environmental fog, and let's try to make a clean render. Also we need to turn off our visibility for our box, so we will not see it anymore. Okay, this is our clean desert before this fog effect in a valley of dunes. And now we will test the color and the distance. Let's set the region render and try to render with this environmental fog. Okay, let's try another distance and the green color, so it will be more visible for now to make a test. Okay, so now we can tweak our distance. Yes, something like this, a little bit transparent. And also we can add cellular map to the density texture. Yes, and this map will define some additional details inside this fake fog. So let's just bring some iterations to the fractal. Let's play with the size and spread. Also the curve is just some improvisation with the parameters. And let's try a small region render one more time. And this is how it looks with the additional texture inside the channel. So we got some details. Let's animate the size same way as we did before to give some like a phase change effect to this map, because cellular map doesn't have a phase parameter, so we can cheat and animate size instead. Okay, let's bring back normal color. We don't need green anymore. We are not testing anymore. Okay, it must be barely visible. Also, it will be more noticeable on a sequence. Static is like not very obvious. At least we see some details, some little shadows, and some color variations above the dunes. Maybe tweak the color a little bit more. This is again, this is just an improvisation with the parameters, just until you like the result. And let's bring more iterations. Okay, I will do the test render behind the recordings, and I will show you the final result of the render with this fog effect. Okay, this is the result. And let's watch this sequence. And as you see, we have a nice dust above the dunes before the explosion. And then our shockwave, it looks like the shockwave is pushing away everything which is in the air above the dunes, also including our texture change after the shockwave. It gives really nice effect, like whole atmosphere is changing after the shockwave. Of course, you could bring more variations, more complex texture, but I think it is already good enough for our purposes. So we can move to the next chapter, and there we will do some extensions to our scene to have a better feeling of the scale of our desert. Chapter number 4, scene extension. This is actually a very easy procedure. The main idea is to fill this horizon area with additional faraway mountains, and we will just copy our existing ground object and cut some parts with the mountains and place them far away. Let's copy our existing ground object, give the name desert extension 1, and move it aside. Of course, for these purposes, you can simulate one more version of the desert with different mountains in Gaia, but I think we are okay to do this with our existing ground. So let's kill all modifiers of this copy of the desert, and let's select area with the mountains and delete the rest. Also, let's clean this little chunk. So we have our small part of the ground with the mountains, and we can rotate to find some unique shape, so it won't be just like a copy of the mountains which we already have in the camera. Also, we can place them in a different distance, and that will have a nice play with our vray environmental fog, because different distance will paint these mountains with different colors. So let's make another copy of the ground and give the name extension 2 and select another part of the ground with another mountains. And let's place it somewhere else to rotation, to fill the right part of the frame. Yes, somewhere here. You are limited with rotation, because if you rotate too much, you will see the side of the object. Okay, I think it is very nice for our case. And now we will make a copy of the material, but this material will have another name, Dune Nuke Desert Extension. And in this extension shader, we will turn off this last layer with the shockwave effect, because that far away we don't have a shock effect on the ground. And we need to make sure that the rest of the shader is static, nothing is animated, nothing is related to our shockwave. I think it's clean. I think just the last layer was with animation of the shockwave. So now we will do the render with the environmental fog on to see our extension, how it works. Also, let's bring our dust, so we will see all these elements. And let's hit the render button. And here now you can see our extension mountains. They are under the fog, which is really nice. But what is more important is our explosion now is not affected by the environmental fog. This is all because our simulation of the explosion is not in the right mode of the rendering. It must be in a volumetric geometry. Only in this mode it will be affected by the vray environmental fog. And this is the problem, because our render time is getting even longer. And this is only with the explosion. Well, now you can see the effect of the fog over the explosion. And now you can compare the difference. Obviously, it must be on. The left side is correct. So our explosion is affected by the density of our environmental fog. And now let's bring the rest of the simulation elements to our scene visible, make it visible, and make them all in a mode volume geometry. And we will check the render time, all of them all together. Every time you will start the render, you will get this notice after you turn on the volume geometry. I will show you what is it in a chapter of render settings. So this is my render, and it took 1 hour and 20 minutes, all elements. And you can see 4 minutes turned to 1 hour and 20 minutes with all elements affected by the environmental fog. Of course, this could be done on post-production, and the rendering time will be much more faster. But I decided at cost of time get physical correct result. So we are ready to go to the next chapter. Chapter number 5, and I'm so excited to show you how we will make the last element of our explosion shot is a missile. So basically it's a rocket in my scene. So first of all, let's lock our extension grounds so we will not move them accidentally, and turn on ignore extents. This is very convenient option, so every time we hit the Z button to zoom, it will be ignored these far away objects, just like they are not visible in a scene. So let's create a line which will be the path of our rocket. This is very convenient way in our case. It will be very easy to control the animation of our rocket, the angle and the speed. So let's adjust the line, something like this. Let's make more steps to make it more smooth. Let's go back to the camera view. And while watching the camera view, we can adjust the line a little bit more. I prefer to keep the path like from the almost vertical. The end of the line must be in the right position where actually our explosion will happen, just in the middle. Yes, something like this. Maybe higher a little bit. Yes, almost vertical. Good. Okay, now let's create the object which will be our rocket body. It is not necessary to make any crazy models here because it is very fast and barely visible, so I used just simple cylinder. Just adjust the size so it will be a realistic size comparing to the desert, and just very basic adjustments of the shape. Probably it is mostly for myself, because I'm not sure that this will be even visible at all. It is just nice to know that the model in this scene has some at least minimal look of the rocket. So I think something like this. Basically it could be even just a cylinder without even any change. So let's move the pivot somewhere in the middle, and then go animation, constraints, and then path constraint, and choose our spline. So now our cylinder will move along the line. Let's bring back our explosion so we will know the timing of the explosion. And yes, it is not very correct position of the line. Must be in the middle. Okay. Let's select our rocket, make a selection set just in case we will need it. And inside this constraint, let's turn on follow and choose the right axis and flip in case we need it to make the rocket align correctly, and Ctrl C to create the camera and link this camera to the rocket, so it will be easy to watch the simulation of the fire from the rocket later. So let's link this camera to the rocket. Yes, now it is good. Let's change the name. And now we need to adjust the timing of our rocket. So let's find the frame where it must hit the ground. It is here, and play with the percentage of the path. So our rocket will be in the end of the line just in time. It is fine if it will move just about below the ground. It's okay. I think in our case it must be something around 5 or maybe 4 frames visible to the camera, so it will be fast enough to look like a rocket. Yes, I think it was something around 4 frames, actually 5. So now let's go and go to material editor and make some basic material for our rocket. I think it must be something gray, green color with some maybe reflections. Not really necessary, but just probably just for myself to know that there is a model with some shape and with some material, and I'll be fine with that. Okay, glossiness 0.8 and fell off map to the reflection channel with some curve adjustments, something like this. And maybe 0.7, 75, yes, around that. Metalness something like 25, yes, around that. As long as it just looks like some metal paint with greenish color. So now let's create the simulation box. Now we can align this with our rocket position. Yes, we need to cover whole rocket body and adjust the size. So we need pretty small one actually. And it's very important, we need to connect this bounding box to the rocket and set these parameters: gravity 0, fluidity quality 1, and let's create source and also connect to the bounding box, so everything will be in the same position for our camera. Oh, sorry, I just remade another camera. Yes, like this. No mistake, I need a camera with no target. Let's align it again to see everything. And yes, and now this camera must be connected to the bounding box with no target, and it will be always looking to the simulation, so we will be easy to see the result of our simulation of the fire. And one important trick for the rocket body, we need to set all polygons to channel 1, ID 1, and the backside ID 2. So later in our in our source object, we will add the whole rocket body, set some outgoing velocity, temperature, and blah blah blah. And here we can input polygon ID 2, and it will emit the fire from the rocket only from the backside. So let's include all these objects to the simulation. Set velocity, storage quality, backup intervals, output cache, destination. And I think we are ready to try our first simulation. Yeah, just set the timeline. So we will start our simulation only at the start of our rocket, not the whole time range. We don't need it. Yes, and let's adjust a little bit the distance which our rocket goes over the line. Make sure that your rocket will not teleport back to the beginning of the shape and will go this path one more time. Okay, so now we can start our simulation and see how this fire looks like. Probably we need to watch with GPU preview mode, I think. Where is it? Okay, it's here. Turn it on. And I think it is too much fluctuations for our fire. It must be more straight. Let's turn off uniform density. It must make our fire more like a straight line by turning on the effect of pressure. Okay, let's see. Usually first several frames of the simulation are a little bit too different to the rest of the sequence. And after 12 frames, now it is more like a straight line. This is actually what we need. Make sure that once the rocket hit the ground and went below the ground level, make sure that your simulation has stopped and not visible above the ground. So we need to set our stop frame for our simulation, because we don't want to simulate this rocket fire all the way till the frame 1330. We can just stop right after the strike. Okay, let's check how it looks on the render. And yes, we see the pretty straight line. Good. Very nice. Let's go to the rendering settings. And let's adjust the curve of our temperature to make it a little bit more maybe transparent or something. Yes, so only the hottest voxels will be visible, and decrease the fire multiplier to make it a bit more transparent. And it must be not very bright now. One more second. Okay, Yes, now it is very nice, not super bright. Or maybe we can bring back some brightness. Actually, it is totally up to you how much fire you want to see from the rocket. Maybe it will be just very little red dot because the engine is almost stopped or something like this. I don't know. I prefer to see this very bright line from the jet engine. Okay. I think now we can bring back all our elements and set up the test render. Not actually all elements, just explosion, maybe shockwave, and try to render the frames with the rocket to see how it looks on dynamic. And of course I will cut the rendering from the recording and I will show you already the final result. Okay, after 24 minutes I got few frames, so I can stop it and show you the result, these frames. And this is what we got. Very nice. This is oh, we don't need the last frame because it wasn't finished. Very nice. Yes, the rocket is fast enough, bright enough, and the timing is maybe one frame forward. It depends, it's up to you. Maybe your rocket got under the ground and then exploded like quarter second later. I don't know, it's up to you. To me it's fine, in dynamic looks good. So the next test will be the whole sequence. I will do the draft render of all elements and the whole range of our scene, and I will show you the result. This is what I got after my render, and I applied same sound effects from my original video. As you see, it is not very long. It could be like 100 frames longer. But I decided to stop my render because it was already like a couple days to render because of, as I said, the vray environmental fog. It takes too much time to render the simulation elements of our explosion. So let's watch frame by frame. And here you can see very well this flying dust when it is over the dark areas of the ground. Looks very nice, and it is matches very well with the sound of the wind. You can see this dust in a valley over the dunes, and the explosion and the shockwave effect and the foreground dust and the rocks. The only thing that I was rendering with very low quality, so you can see these spots. This is because my rendering settings, and I will show you on my scene in the next chapter how to set the clean render to avoid these artifacts of the render. But overall it looks very good, and I would say the explosion itself, the mushroom, looks even better than my original project. So now let's jump to the next chapter and watch the rendering settings. Okay, this is my original project scene, and I will show you my rendering settings here with the focus on the parameters which are related to the quality of the image. And let's begin with the explosion. So let's unhide our layer with explosion. And here our mushroom. We can select it here because I didn't hide the boxes. I don't know why. Probably I was doing something here in the scene. Can turn off the box. Okay, this is the setting number 1, which is related to the image of the look of the explosion. So how much details you will get. So this is probably 90 is the value which you shouldn't reach lower than this. So everything is fine between this to maybe 200, like here, maybe 400. If you are fine to skip some probably details in your cache, but you will get faster rendering time. So this one, keep in mind this parameter. So let's go first, and one thing, keep in mind this one, the mode, volumetric geometry. This is mandatory if you are using in your scene this I don't know why it was turned off, this environmental fog. This option is mandatory. So let's go and watch the volumetric options. And this is settings for fire. And here the graph could be different in your project. It depends on your simulation. And here you can notice this parameter. The lighting light resolution is only 3%. So 3% of the cells from the simulation is counted as the lighting source. I think this is pretty good value. You shouldn't go higher. I think everything above 5 or 10% will be unnecessary for this project. So let's go next, smoke color. And here another very important parameter for the speed of the render and clean look without any bugs or like a spots like you saw on the render in my previous chapter. So this parameter for the explosion is almost 1. So this is very high, and keep in mind, maybe in your simulation you need to go down. So everything which is lower than 0.9 will be pretty slow on your render, but will give you more clean look. But in my case, I decided that this amount, almost 1, it is still fine, and it is not causing any troubles in my render. So next, the smoke opacity. Here actually the only one parameter which is related to the speed of the render, maybe is this one. So basically this is kind of like a threshold which cuts from the rendering every single cell of the smoke which opacity is lower than this parameter. So if your cell with the smoke like somewhere here at the edge is like 0.002, it will be invisible for the render, and it will of course will speed up your rendering time. So this is it. This is the core explosion. Let's go next. and watch dust wave. Let's unhide this layer and select dust wave. So here again, volumetric geometry steps, I decided to go 400 because the difference in my case, difference between 90 or 200 and 400 was not very obvious, but the difference in time, render time, was quite significant, so I decided to go this amount. And let's watch volumetric options. So fire, there is nothing because it's just a dust wave. Smoke color, cache speed up 0.9. I think this is a sweet point, sorry, for all smokes elements. In most cases, this works fine, 0.9. And smoke opacity, here I decided to go minimum, so almost every single cell is visible for the simulation. And let's go next, and it will be the light dust. And in my scene I have 2 light dust simulations. I will show you. I have, here's my camera, I have the front part of the light dust and the back side, because in my scene the camera was a little bit higher, so it was a little bit visible, but the settings for them are identical. And this is the settings. So steps 200, volumetric geometry, and here fire is disabled, of course, and light cache speed up was 0.83. I had to go this value because even 0.9, which is totally fine for the dust wave, here was causing the troubles with those spots, red color, light spots over the simulation. So I had to go even lower value. And minimum visibility, I went 0.007. So I skip pretty a lot of really transparent cells. This is also for the render time, because with something around 0.1 it was really crazy to render, so I decided to go 007. And the last simulation which I have here is near dust, and near dust is has these options. So steps 90, I was keep trying to get as much as possible details from this super close-up smoke. Let's wait for the viewport update. Yeah, this one, because it is super close to the camera. Actually, it is reaching the camera, so I was trying to get as much as possible details here. And fire is nothing. Color smoke, the speed up was 0.9. Again, this is the sweet point. And visible opacity minimum. So I actually could go 0 for this case. So this is all my main simulations. Let's hide them back. Also, I can show you my missile simulation rendering settings, but it is barely important for this case because it is very small. So the steps 90 and light resolution is 5. Here speed up is default 0.9. Another thing which we need to talk is our fog effect. We have two of them. This one is for the whole scene, and here the values which you need to take care is max steps. 8 was pretty fine for my situation, because what is it? I have no idea what is it. Sorry. 8 steps was pretty fine for my case for this scene. I think anything above 12 maybe will be unnecessary and will take more time for the rendering time. It will just slow down your process. Step size 50, and probably that's it. There is nothing else which is important for the rendering time. Second, environmental fog has steps more. I think this was just a default, and I leave it just with no change, because the rendering time before explosion, before we see all these crazy cache volumes, the render time was pretty fast, so I decided for the smoke which we can see over the dunes could be this detailed. So now let's go to the rendering settings, and important moments there will be image sampler. I did my render with 1 to 8 and threshold 0.01, but this is again up to you. You can go something like 216 maybe, and it will give you even more clean look. So your close-up ground will be super detailed, and the noise will be just minimum, maybe even higher. It depends on your workstation. But for me, I decided that 1 to 8 is a very good balance between quality and result. Here is nothing, I didn't change anything. Color mapping was default. Camera settings, it reads from the camera all data. One important thing here is max transparency levels. This is related to the little notice, the message which gives you the vray engine. Once you start rendering your cache with this option, volumetric geometry, it will read this parameter for calculations, and this is very important thing. By default, here is something about 25, I guess. It could be different in different versions of the vray, but it is very low in the default. I think it was 25. And in this case, sometimes when you have lots of things in a big scale, so the difference between distance to camera is significant, like some smoke is near the camera and something is in the middle, and some caches are like far away, like here behind the explosion. It may give you some problems, like kind of like a bugs in your on your image, and this probably will be related to this parameter. So if you want to keep your huge scale scene with the environmental fog and in this mode, volumetric geometry, you need to increase this parameter. But this parameter, increasing this parameter will slow down your render a little bit. I think for most cases, 200 is totally enough. Maybe even 150 is okay. Uh, for your case, you probably will have to do some test renders and you'll see what works for you better. But for my case, I decided to go like overkill value 500, and it was very smooth in a feeling of the volumetric fog over my cache objects and geometry in my scene. So don't forget to play with this parameter and find the sweet point for your scene. The rest of the parameters are basic, nothing special. I did my render in to EXR format because it gives very wide range of the image of every pixel, so you are more flexible on the post-production, especially when you are trying to adjust your white points of the explosions which over brightened by the fire, or super dark like almost black shadows. So in EXR format it is possible to fix on the post-production. In the settings, I didn't change anything here. I just switched the sequence of the rendering from left to right, from the basic, I forgot what is the basic spiral, I guess, something like this. So I decided to go left to right so I can see the result of my render from left and it goes to the right side. In GI, I didn't change anything, and it was just default, absolutely default. I didn't change primary engine, secondary engine, this brute and light cache. I actually even didn't know what parameters here, so yeah, it is default. And I didn't use elements here in this project because I found that the way which Phoenix works with the elements, it is not very flexible for my point of view, so I decided just to work with the picture only with the RGB channel, and I didn't use any render elements. And probably the last thing which I can show you is not probably related to the rendering quality, but it is related to the image quality actually. And this is the settings for my vray displacement for the ground. And this is my settings. So here, these parameters are important for the quality of the ground displays. So I went the edge length 4 and max subdivs 256. So this is it. This is my rendering settings, and overall I showed you all parameters and all values from my whole scene. And now we can jump to the last chapter with post-production, and I will show you how my draft render got its cinematic look and all effects. Well, this is the last chapter of the tutorial, and here I will show you the post-production of my project, of this shot. And as I mentioned in the first part of the tutorial, I made my post-production in the Fusion Studio, but the adjustments which I made here are actually easily could be done in any post-production software. Is totally up to you which one to use. I believe even in the basic software you could do something approximately similar to this result. So let's begin from the beginning. In the Fusion it is from the left side. So these nodes basically is just your input of the frames. Why it is not just one single node? It is because I was bearing the situation with the negative frames in 3D Max. I had minus 40 the start of my time range, and this is why I had to render not render, I had to import to my post-production software independently the negative part from minus 40 to 0, and then I imported the rest of the sequence. So and this is just an loading of my frames to the program, and you can see, and this is with gamma 2, or sorry, gamma 1, because it is EXR and it saves the file with gamma 1. The next node, the only thing it does is just bring my gamma to 2.0. I decided to not go to 2.2, but this value was actually fine for my case. So basically this is just your loader in case if you render just PNG or JPEG files or something like this with already gamma 2, and this node is just your loader nodes. So this is not even the post-production yet. So let's move to the next, and here my first color corrections nodes, and the first one what it does, let me check. Oh, okay, in this node I just bring the saturation for the for my highlights a little bit lower, so probably you can see this here. Before it was like this, and this node brings the saturation a little bit lower, so it became more like a desaturated a little bit. The next node has more significant changes to the image. So what it does for the shadows, it's like these dark areas, it brings contrast higher. This is on and this is off. More contrast in dark area. For midtones, it has some bring down the saturation, and I play it a little bit with contrast, a little bit higher, more gain. I brought gamma to 0.7889, so I just made some more contrast with this node. So these two nodes is just saturation, gamma, contrast, play with these parameters. So next is this construction. It looks complex, but the only purpose of this here is I fixed my little trouble of my simulation of the core explosion. It was in the really beginning. Here I have these variations with the very bright area in the beginning of the explosion here, but then suddenly I got this darkening and my brightness went down for a few frames, and then it got bright again. So it looks like a bright, 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 2 frames dark, and again bright. So to fix this problem with the post-production, I decided to make this mask. I rendered it separately, not as inside the main rendering sequence. And I just made a mask of my explosion, and with this animated, this is the keys on my timeline, with the animated contrast gain. So I brought some brightness for these 2 dark frames here and here to match somehow the normal look of my explosion with the bright fire and at the beginning and in the rest of the sequence. These 2 dark frames I fixed with this node and the animation. So probably in your simulation you don't need this as well. So let's continue. The next node is here, and if you can see, it brings the colors of my scene from a little bit greenish tones to more colder one. So I just went to mid-tones, and in the channel blue I decreased the contrast. So you see, if I'll play, you'll see it just make more colder the look, the temperature of my scene. So basically this node is just like a temperature control. Even in Photoshop you have it. The next node is even more tone corrections. So as you see, it brought even more colder look to the skies especially. So if you compare to this position with this node, my sky is like green or yellow colors, very warm, and after these 2 nodes it became like normal, like blue skies. Also it affected my rocks. They became more cold look as well. The next node was again I played even more. I brought down, I suppressed my yellow colors and red colors in mid-tones, so it is not affected. It didn't affect my explosion, because explosion is highlights. The mid-tones is basically my desert. So I suppressed my yellow colors, and if you'll see, my scene got even colder. So these 3 nodes, I actually just brought my temperature of my scene to more like a bluish colors, like more colder one. So let's go next, and this one is just a glow to my explosion, and this glow is kinda very smooth and with the very wide range. So if you see, with and without, it is very, very soft. Even when the fire is maximum on the screen, it is kind of soft and gives you a reddish halo, which ignites or illuminates your air around the explosion and gives you more better feeling of the temperature around the fireball. So now it looks like a kind of cold explosion, not very hot, and with this glow it got really hot look. The next node is also glow, and I made it even brighter. It's just two different ways to make the glow effect. This one like more softer, but here the threshold is lower, so it gives a little bit more glow. So these two nodes is just adding glow. So one more time. This is the draft render. This one is just play with the saturation. This one is just fix my simulation bug. And these three nodes, I brought a cold look to my scene. These two nodes is just a glow. And go next. This is the sharp node, and this sharp node has some animation, so it starts from 0 in the frame before explosion, and it got more powerful around this area, and in the end it got again to 0. And what it does some sharpness to my area with this mask, this circle. So this is the sharpness for my explosion area. You can see it if I'll zoom it. This is with this node, and this is without, and you can see it gives you the feelings of more details in this area just with the sharpness. Another node, the next one is film effect. This is the very complex node. It has a lot of parameters, but actually this node I use for some colors play to kind of bring some filter to my image, and you can actually achieve the effect of this node with some curves. If you play with the curves separately, like green, red and blue, and you can achieve. And let's watch the result of this node. And basically you can notice that this node gives barely visible colors change, but it gives more like a brightness enhancement. So before this node, the scene looks like almost before the sunset, so it is like a very late evening. And with this node I made it like more look like a daytime, just the overcast cloudy weather, but daytime. So basically you can make this effect with some brightness control, exposure, probably with exposure, yes, and curves also can give you the same effect. The lens flare, probably everybody know what it does, and it brings some additional light effect. You see, it is just very big, huge actually, over the whole my screen, so you cannot see those like a real small circles which you used to see when you hear about lens flare, but here I use it just like a huge scale. So this actually looks like my glow effects, like this too. So this increased my glowing of the explosion. This node, it goes shake, so it shakes additionally my camera, because when I checked my render very carefully, and I decided that my shake from the camera in 3D Max was not enough, so I decided to bring additional shake to my scene with the compositing. and this shake turns on only at the moment when you got hit by the shockwave. So this is with shake and this is without. As you see, it shifts the image a little bit more to the side, and also I turned on for this node the motion blur, so it is not just shifting my image and shaking like this, but also it includes the motion blur effect on this move. And transform node is just a compensation node to the previous one, because shake it actually moves whole the image to the sides with some frequency, and sometimes from the edges you can see the black area or transparent area because your image was shifted too much to the side by the shake. So with the transform I brought some scale up. You see this this bounding box says that the image is a little bit scaled up to prevent possible some troubles at the edges after the shake. So these two nodes is just shaking, additional shaking of my camera. So let's go next. Let's choose better frame with the explosion. Okay, so right here. Next node is additional sharp, and this sharp is actually activating in this time range in the end of my scene. So at this frame it is still 0, and it gets its power in the end to bring some more details of this dusty environment after the shockwave. So let's watch without. You see the image is a little blurred and not very sharp, and this is with the sharpness without and without and with, you can see. So let's go next. Additional color correction, and this color correction is also turns on only in the end of my sequence. So it starts from this frame when we already are under the shockwave effect, and it is getting the maximum effect in the end. And what it does, it just brings my view, just make it darker, so it's kinda effect like a dust and sand is covering my sun, and I cannot get the light anymore from the sky. So this is like a fake effect for darkening my sunlight. And you can see the effect starts from here and is getting darker and darker and darker, and this is the maximum. So we are like in a huge clouds of the dust, and we cannot get the sunlight anymore. So this is the fake effect of this darkening. Another node is the glow, and what it does, it brings some after the node of darkening, I tried to keep the contrast at least in my skies, to give at least some even minimum bright areas on my image. So this node is just taking and increasing some light from the sky. So without these two and with the next node is just a defocus, and it also starts from the point when we already under the effect of the shockwave, and the maximum power is at this point. So what it does, it just gives me additional defocus here when we already covered with the shockwave, and it gives the feeling of that the eyes of the viewer, of the person who is watching this explosion, and it is it's just losing the focus, the focal point by his eyes or the camera after he was hit by the shockwave and the dust. So this node is increasing my darkening nodes. So without this 3, it is still sharp and bright, and maybe looks a little bit boring, but with this 3 we are like in the cloud, and we are defocused and maybe disoriented, so we cannot focus on the objects. And the next node is flickering. So what it does, it is actually adds some very subtle flickering to the whole image, and this is like an imitation of the sand which is flying above our camera or head of the person who is watching this explosion, and it is changing the lighting constantly. So it is just covers the rays sometimes with some amplitude and the frequency. So it just gives me some variations for the light. It's difficult to show on a static image, but it is kind of obvious when you play the sequence. So it gives some flickering of my light. And this node is also a flicker, but I call it overdose. And this flicker works only here when we are already in the in this cloud of the dust or sand, and it flickers even more. You can see, yes, this frame is bright, and this frame is darker. You can see this difference, darker and brighter, and this is the result of this node. So it adds crazy powerful flickering when we are inside this cloud. So it is increasing my effect from these nodes with darkening and defocusing to give you feeling that you are in a dust cloud kind of wave or something. So these two nodes is just to flickers my lighting of my image. And what is next? And next is actually the last node. This is it. This is just a grain. And to show you the grain, I will move to maybe this frame. So this brings some grain to my image. This is without, and this is on, off, and on. And what I did, I took the Luma data from the image, and I adjusted with the curve to make a separation of bright areas here and dark areas. So I am applying my grain only to the dark areas of my image. So if you go back to the original image, so you'll see this is the dark area, and this one, and maybe mountains. So there you will see my green. Sorry, here it is off, it is on and off, on and off, and it is almost minimal to the bright areas like the sand here. So you see it is changing on the mountains, but it's almost invisible on my sand, because I was trying to deduct the sand and the bright areas from green. So this is it. This was the last note of my post-production, and this note is already out to EXR. So one more time, this is just a raw render. This one is gamma. This one is just very subtle saturation and contrast adjustments. This one is just a fix for my brightness of the explosion, but you can skip it. You probably will not have this problem in your project. These three nodes is just temperature control. So you see my image become more bluish, more cold environment. These two are just glow. This one is sharpening of my explosion mushroom. This one is brightens my image to the daytime. Additional flashing from the lens flare. Additional shake, but it works only at the frame of hit by the shockwave here. And this one is compensating the shake effect to prevent some edge problems. One more sharpening, and color correction. And this color correction, glow and defocus works only here after the hit by the shockwave. So this three is this effect. These two are flickers. This one flickering my whole time range, and this one flickers only the end when we're already after the shockwave. And the last one is grain. So this is it. This is whole compositing project. So now you know everything about the Nuke shot, how it was built from the really beginning, from the core explosion till the desert and the post-production. So I really do hope that you enjoyed this tutorial, and sorry that it was too long because lots of things to discuss and show you. I hope you enjoyed and learn lots of things here. So make sure that you will not miss the new tutorials and projects on my channel. Thanks for watching, thanks for feedback. See you, bye bye.